Okay, now we get into some R basics. We need to understand some basic concept of R in order to conduct statistical analysis. So let's get to the R code file. We have the R code file, R basics here. So this is the code for R basics. You can see I put a lot of comments here. This code is for week 10 R basics. And we can see those sharp signs, those are signs to mean that everything behind this sign is a comment. It's not an executable, R code. So everything behind this sharp sign won't be executed. So you see this RM function, no sharp sign. So the R will directly, run this code. But the rest of the code are just comments to show you the meaning of those R or some notice. Here I put several tips here. For example, tip 1, you can run R code through Control Enter in Windows or Command Return on Mac. All right, for me it's Mac, so just Command Return. You can see once you run this code in the script window, and the result will be shown in console window, right? So this statement means clear memory. We just clear everything in the environment, okay? So let's get started. First, we need to understand data types. So in previous week, we understand there were 3 different data type in statistics. One is continuous, ordinal, and nominal data. Continuous data are data number means numbers, which means 3 ducks, 4 flowers for 5.2 meters, 45%. Something like that. Those are the meaning of the numbers. You can plus, minus, multiply, divide, all the mathematical operation can be done on them. The second is called ordinal data. The number means orders. So for example, university ranking. So rank 1 means the best university. Rank something else, maybe 50 something is maybe the top 50 best university, right? The other example is Likert scale. 1 through 5, with 1 extremely not satisfied, 5 extremely satisfied, and 3 neutral. These are all ordinal data. And nominal data are number means names, a label, or symbols. So for example, in our class PIA 6204, 6204 has no meaning of 6,204, right? It's just a symbol of this class. Right? We have other classes, for example, PIA 5603, right? Some of you have already taken the class in that one, right? So that's the data type in statistic. But we have data types in R. So those are the data types that R store those data, and R store those value of data in something called variables. Okay, so on the following we can see we have a variable name and a value. So variable is a basic element, and we have 1 element variable. We can also have a set of element in before. When we talk about data structure, okay, we may have multiple elements to assign them into 1 variable. So variable is a basic element in R. And the naming convention in variable is just a combination of letters, numbers, and dot and underscores. But be aware that dot and underscore cannot be used as the first character of the variable. Okay, you can use them anywhere after the first one. So we can name a variable called v1, but we can't name a variable as 1v. Okay, the first character must be an English letter. And in R, the names, everything is case sensitive, which means capital letter V is different from small case v. Okay, they are different. So small case v1 is different from capital letter v1. There will be 2 different variables. Okay. So here we can see there are several basic types in R. First, the double type. We assign 3.14 into v1, double type. But by default, every number is set as double type. Okay. We have second type, integer type. We have to use integer function to create an integer type 3. So if we directly assign 3 into this variable will be double. If we use the function here assigned to the variable, this variable will be integer. Okay, and the third one would be character. Okay, when you assign a string, an English word with a quotation mark, then the type of this variable will be character. Okay, and we have the logic or something called a Boolean value. So we can have true or false, only 2 values. So true is the logic value, and false is a different one. And we have two special data type. One is called factor, the other is called date. So without this s dot factor, when we assign h to v7, it will be an correct type. But if we use this function s dot factor, we'll convert this correct type variable into factor type. But if you use type of, it will only show you an integer instead of a factor, nor a character. Okay, so that's how R store factor type. And we can have a date type. We can, convert a date into a date type, but R store the date type as a double type. Okay, and we have other types here. Okay, so in our code, right? Let's go see here. Double type. Let's command return to run it, and we see the type of v1 is double type, and type of v2 is also double type. Type of v3 is integer type. You can see here, right? Double integer. Even though this here is an integer 3 here, we have to use this function to make it as an integer type. Okay, we can see correct type, right? V4 is a correct type. Okay, so here's a my name. Okay, it just show you this is just a variable name. Okay, here's a logic type, right? You can see logical, right? Here's a factor type. Okay, you can see v7 is h is a factor, but the type of v7 is integer. Okay, and we can here we can create a different factor. Okay, if we see v7 as this, right, and still original v7 is still character. Okay, when we use a factor, right, then we see v7 it become integer again. Okay, and date type, we saw data type double. Okay, we have other types. NA means not applicable, which means it's a missing value. Remember, this is a NA missing value. Okay, V-nice NaN means the value is not missing, but it's not a number. So for example, if we try to plus two variables together, for example, we try to say 1 plus v9. Okay, but v9 is a string. Suppose it's hello. How can you put 1 plus hello? You have to do some coercion thing, right? And it might show you. Let us try this here. It may not. Well, if you use 1 plus hello, well, it will work, but it will transfer 1. Okay, right? Non-numeric argument to a binary operator, right? So this is numeric. Hello is not, right? But it's in other types. So when you do other analysis, this NaN is not a number type. V10 is null, which means empty. Okay, so remember, V8 is missing value. So there should be some value there. We just missing. We don't know, right? V10 is null. There should not be any value there. So that's the difference. Okay, that's all the data type. Now we understand data structure. Okay, so remember, here is a graph. I steal it from the book or in action here. It shows different data structure. Okay, we've known this. Assign one value to a variable, so just one element variable. What if we have a sequence of variables, a sequence of the same type? For example, this v2, we assign ABC. So v2 is a vector because this is a sequence of 3, characters, right? And what if we have 2 dimensions right here? But in matrix and array, we can only have numbers inside. We cannot, assign those character type into matrix and array. Okay, and list is like for every entry we can use different types. We can, for the first entry we use vectors, second entry with array, third entry data frame, fourth entry list. Everything can be as an entry in a list. Okay, and data frame is a special case of list. Okay, so V6 is a data frame. For type of data frame, you will see it is a list, but why it is a special case? Because for each entry in the list, it should be the same length. Okay, I'll show you in the code. Okay, So let's remove again this sentence, this data. Again, we run it, everything here, empty. So it's clearing the memory, okay? So first is one element variable. V1 is one element, okay? Then a sector, right? A vector means V2. So V2, we can type V2 here, okay? It contains 4 entries for each of them A, B, C, D. So here, 1, 2, 3, 4, with a comma here to separate them, okay? V3 is a list, okay? So we try to assign one element, a sequence element, into one list. So V3 is a list, right? First entry is just one element. Second entry has 4 elements, right? And we have different names, okay? Can see length of the first, length of the second, right? Matrix. For matrix, we have to use all numbers. We can see it's 2 dimension because then we have 5 rows, 4 columns, and fill the number 1 through 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's by column, okay? Assign 20 variables there, right? Okay, array. Array means multiple dimension, okay? So here's V5. It's a 3 dimension, right? We have, for the first dimension, we have A and B. For C2 dimension, we have A and B. For C3 dimension, so we have C1, C2, C3, C4. C4 dimension, we also have A and B. And we assign different value, right? We can 1, 2, 3, 4, 5, 6 for C1. So for array, it's just multiple dimension. For matrix, it's 2 dimension numbers. Array we can have n dimension, conceptually, but we seldom use those 2. If you are using 2, probably get into very advanced R skills to faster your calculation. The most commonly used data structure is called data frame. So V6. This is how we create a data frame. So a data frame looks like this. It's like an Excel table. They have rows and columns, okay? And we can use a $ to select a column. And we can see the type of a data frame is a list, okay? V6 is the list, okay? So that's why we see a data frame is a special case of list, okay? Then after we understand the data type, the variable type, and the data structure, we come to parameters and functions. Functions are quite important in R. There are generally 2 types of functions. One is called system-defined functions, which is defined by our core software. The basic software is embedded in the R. And just after you install R, you do not need to install any packages. The functions are there. So those are called system-defined functions. There are also some functions can be defined by user themselves. So that's called self-defined function. It's in the format of a function name, assign the value function with the function, syntax, and then we use the function, okay? So here example, okay? In this self-defined function, we have, 5 functions in this code. We have C, okay, this is system-defined function. It creates factor. We have data frame, okay, it's a function to create data frame, okay. We have nchar, which is nchar, okay, it's a system-defined function to calculate the number of characters. Okay, we have substring, a system-defined function to to excerpt a string from original string. In this way, we substring from X with the starting position L minus N. It should be +1. I forgot to have this. Okay, L minus N +1. Okay, until. So this is the format of self-defined function. Okay, parameters are like X and N's. They have no meaning. They are not predefined. They have no meaning inside, outside the function. Okay, because we haven't defined anything about X, but it's like a representation. You need to pass 2 values into this function. The first value is X. The second value is N. For the first value, we need to calculate this. for the second value, you need to calculate this, and we use this to get a final result. Right? That's the value. So how can we use this function? We use this print.lastnchar. This is the name of the function. What is the first value? X. It's v. I am Michael. Okay. What is the second? What is the value of the n? This parameter is number 5. So that means we try to calculate the last 5 character from this v, this character. Okay, so here how do we system defined function. If we only type C, we'll see some description of how can we use it. Same to data frame. If we hit this, it will show you how this data frame is created. You can see it's quite complicated. You don't have to memorize this. I just show you. Okay, just an example. Now, how can we define a self-defined function? We try to define a function called print last n char. Print last n means the number. Here's last 5 char, 5 character. Okay, I try to print the last 5 character. So just click this, and we see after we define this function, we execute this function. Okay, v is not fine because we haven't. Let's assign v equals this less than dash sign means assignment. Okay, assign a value to a variable. Then we run the function again and print the function again. EL space wu, that is 1, 2, 3, 4, 5, the last 5 character. So a space is also counted as a character. Okay. Here's a different function. This is paste 0. This one is also system defined function to paste the strings together. Okay. See, paste 0. See, you are not MIC, right? Then we pass this value, EL space wu. After this, you are not MIC. So you are not Michael Wu. Okay. That is how we see the variables, data structure, and permission function. Okay.